Hello everyone, welcome back to my channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and try to solve it together. Okay. So we are asked to find the longest binary subsequence less than or equal to k. You are given a binary string and a positive integer k. Return the length of the longest subsequence of s that makes up a binary number less than or equal to k. So you can note that the subsequence can contain leading zeros. The empty string is considered to be equal to 0. A subsequence is a string that can be derived from another string by deleting some or no characters without changing the order of the remaining character. Okay, this is the definition of subsequence is restored. So there are conditions that it can have leading zeros. The empty string is considered to be equal to 0. And you need to return the length of the longest subsequence that makes up a binary number less than or equal to k. Okay, k is given in decimal. So if you select something in the longest subsequence, and if you convert that to a decimal, that should have a value less than or equal to k, and that should have a maximum length in this subsequence. So then I need to return that maximum length. So you see the longest subsequence that makes up a binary number less than or equal to 5 is here. It's given to be 00010 because it's something like 2, and this number is equal to 2 in decimal. So note that these answers are also possible. 00100 and 00101 are also possible, which are equals to 4 and 5 in decimal. The length of the subsequence, all of them subsequence, is 5. So 5 is the maximum thing which we can obtain here. Okay. So let's try to see the approach of this. So I will definitely ask you to solve this on your own at first, because uh, this is a kind of problem, because if you try to do it and if you are approaching in the correct method, this will be a very easy problem. Otherwise, it will be a very difficult problem if you try to approach it in the wrong way. Okay, so it's a very interesting problem also. So you should definitely give it a try on your own and then continue watching the solution. Okay. So first thing, I will write some observation. Okay. So first observation is that what do you mean by selecting a subsequence? Can you say that selecting a subsequence? You are asked to select a subsequence. The first thing which comes to mind is that you need to select a subsequence. So selecting a subsequence, is it equivalent to deleting some characters? Is it equivalent to deleting some characters? The remaining one, right? You need to delete the remaining one. Okay. So now you are given a binary string. You are given a binary string. Okay. You see this kind of binary string you are given. And you see, let's say you have some more zeros here also. Okay. You have some more zeros here also. You need to select the largest length. You can have leading zeros. So the thing is that this whole number represent a decimal number, right? If you try to see this whole number, it itself represents a decimal number. What is that decimal number? It is nothing but this is 0, this is 1. So it's nothing but this 1 into 2 to the power 1. Okay. And this is 2, 3, 4 plus 2 to the power 4. You know how to convert binary to decimal, right? So you see, this is the thing. 32 plus 16 plus 2. It's nothing but 50. So this whole number represents 50. And let's say you want to bring it to something k, which is 5. Okay. You want to bring it to something which is less than 5. You want to decrease it to less than 5. Think it in this way. Okay. So you want to get the maximum length also, which is possible. So what can you do here? What can you do here? So if I ask you, you want to get the maximum length. So is it equivalent to deleting the minimum number of characters? Minimum number of characters or digits, whatever you call it, minimum number of digits you need to delete from here and bring it below k, and bring it below k. So the thing is that it is now 30, right? I need to delete min characters. Okay. And bring it below 30, below 5. Bring below less than 5. less than or equals to 5 uh, by having maximum length. Then only it will have maximum length. If I delete minimum number of characters, then only it will have maximum length, right? So you ask yourself, you are given a number, you are given a binary number, okay, which digit should you remove? You should ask yourself this question, that which digit you should remove, okay, which digit to remove in order to lower down the in order to lower down the number by maximum amount. So you are, let's proceed it in order, right? Let's say you are initially told to remove only one character and bring the number to maximum lowering possible. Okay, so let's try to write this number again, 0001100. Okay, write this number again, 000110010. So which you are asked to tell me that which digit to remove in order to lower down the number by maximum amount. So with this number 250, you want to lower by maximum value, lower by max value, and you need to remove one digit only in binary. So you will remove the most significant one. This is the most significant one, right? It's quite intuitive now, I guess. Most significant one. So I think you can also solve it now. You can also easily solve it now. Once you remove this, you have technically subtracted 2 to the power 5, because this was in place 5. 0, 1, 2, 3, 4, 5. This was 5. So you have subtracted 32 from it. So what does it remain? It remains only 18, right? You have subtracted 32 and it remains only 18. So you see, again, it is still not below 5. So you want to reduce it again. Then again, you go and subtract the most significant digit again. So now you end up in subtracting. First, you end up in subtracting to the power 5. Then you end up in subtracting to the power 4. So you have 2 remaining. So by just removing 2 of them, removing 2 digits, you get to something which is less than equal to 5. You get something which is less than equal to 5. And since you have ensured that you have removed only the minimum number of digits, you see what are the remaining digits: 0, 0, 0, 0, 0, 1, 0. So you have a length of 7 remaining. Okay, and this is only the maximum length, because you have removed only the minimum number of possible values. So another observation in this approach is that you need to code it also, right? So you need to make some observations also. So another observation is that uh, all zeros remain intact. Okay. And second thing is that keep selecting one from the right hand side. Keep selecting some ones from the right hand side unless it exceeds k. Keep selecting ones from RHS. Okay, from right hand side, you just keep selecting some ones unless the number formed uh, just exceeds k. Unless number formed does not exceed k, you can tell me. Doesn't exceed k. So you do understand, right? How simple is this problem once you do in the correct approach. So it's very simple and very easy now, I think. I think you will be able to do it easily now. So still, let me just show you the coding portion completely. Okay. So what to do? You need to select all the ones and add it to the length of your answer. Okay. So you have an answer 0. Okay. What you need to do now is very simple. Is that you have this n length also, which is nothing but string dot size. You go through starting from 0 to n, go to them, and what you need to check is that if firstly, if s of I is equals to 0, I will just increase my answer because 0 is always taken. 0 is always taken. Okay. Now, I will just go through again. I will just go through again. Okay. This time I will go through the back because this time I'm selecting the ones. So I will go through the back. Okay. I am going through the back and I am telling that if s of I is equals to 1, okay, if it's equals to 1, you do something to me. You do something to me. What will you do? You first of all create a binary number, binary string, which you will convert to decimal. Okay, string binary, which you need to convert to decimal. Okay, so for every time, whether it's 0 or 1, I will append this something to the binary, right? So I will do binary plus equal to s of I, whether it's 0 or 1, irrespective of that. But if it is 1, whether to include it or not, I will understand that by first converting that to decimal. So if I convert that to decimal, what will I get? Let's say I write a function decimal which converts this binary number to decimal, converts this binary string to decimal, okay, and tells you that if decimal value somewhere if it exceeds this decimal value is less than or equal to k. If it's less than or equal to k, then what you do is that you increase answer because but that one, if it is still less than k, if it is still less than k, I am taking that one. Else you just break out from the loop. Else you just break out from the loop. Okay, you do not want any further ones. Also, you just need to break out from the loop. Uh, and you do something which is return this answer. Now you need to write this thing which is convert this take a binary string and convert to decimal. It's very simple. I think you can already do it. So you see the number is taken in reverse order, right? I am appending the number from the back, so 0 1 0 0, this is taken in reverse order. So if you see, if I am taking that in reverse order, it means that while I am converting from decimal to binary, I do take the decimal digits also from reverse order, right? So I mark the least significant as 0 and the next least significant as 1. In this way I do. So you do not need to reverse. If you are thinking that you need to reverse something, reverse the string since it is already that, you do not need to reverse. What you need to do is very simple, is that uh, you just need to return the decimal value. You just need to return the decimal value. So you go through all the bits. You go through all the bits of this binary number. Okay. And you just do decimal if binary of I has something which is 1, you just add that to 2 to the power this. Okay, so this is nothing but 2 to the power I. I'm adding the decimal to 2 to the power I. So I hope you know this already, right? In order to convert binary to decimal, I hope you know this. I'm not explaining this to you. And return the decimal value. We should return the decimal value. So let's try to run and check if it has had some error. Okay, or it just runs fine. So you see there is accepted, but there will be some error, I think, because you see the error which comes is that the shift exponent is too large for a 32-bit type integer. So what do you mean by this? How it is happening? Try to think is that, let's say you have something like you are iterating through this. Okay, you are adding one left shift I, you are adding 2 to the power I, you are, let's say, in the something which is 25th digit. Okay, then for 25th digit you get some 1, then you keep getting 0 0 0 0, so you do not bother about adding 2 to the power I in such cases. And then in the 40th digit, let's say, you get some 2 to the power I. Now 2 to the power 40 is a very large value, right? It cannot store in integer. So you can know that 32-bit integer stores something like 2 to the power 31 minus 1, you should know this, right? So I should take care that whenever I exceeds this 32 value, you should break from the loop. Just break from the loop. Okay. Do not do anything. So you are breaking from the loop here also, right? So what does meaning of breaking from the loop means? You cannot take any more numbers. So this a is already integer. So if it is exceeding the bounds of the integer, if it's exceeding the bounds of the integer, no need to do anything. So I write here something like binary dot size value is exceeding 32, it means that I have already taken 32 digits. The next digit which I will take will be something to the power 32. Then do not need to do anything. You just break from the loop, because so large you have already exceeded k. You cannot compare it. It is so large that you cannot store it in an integer. What will you compare with k? Okay, so you already have this. So now if you try to submit it, will it work? Let's see. You see, we get accepted, and it has also has 100% runtime complexity. So we are doing quite good in this runtime here. So that was all. That was all for this problem. This was a medium problem. If you can catch the correct method to do it, this is very easy. Otherwise, it might be very difficult also. So yeah, that's all for this problem. I will meet you in the next video. Till then, thanks a lot.